Now, dear student, we have to enter into the next part, coil. What is the role played by the coil? Right, now coil. This coil is of the rectangular shape. Now let me just start from one by one. Why we are taking the rectangular coil? Reason is that I think you all have the idea at the vertex of side of the rectangle there will be a formation of 90 degree. Means each side of rectangle always act at an angle of 90 degree. Why I am saying this? Let me say you. When you enter into class senior section, I think in 10th also we are explaining that current carrying coil, current carrying conductor always experience an amount of force. And if you have remember, agar aapko remember ho to, that force is the vector quantity and that's always equals to BIL sin theta, right? You doesn't have to read this derivation. आपको ये derivation पढ़ना नहीं, ये 12th में आप पढ़ोगे. But let me say you, whenever we have a current carrying coil and if that current carrying coil will be placed in a magnetic field, याद करो हम लोगों ने डील किया था, एक मरकरी का पॉट लिया था, आप याद करें. इन दैट मरकरी पॉट वी आर प्लेसिंग द वायर, वी हैव अ करंट कैरिंग कंडक्टर, देन द horseshoe magnet, and as we press the key the deflection shows by the conductor. Let me say you, if there is the deflection, that means there must be the force, and that force for a current carrying conductor is always equals to BIL sin theta. अच्छे से याद रखना है इस एक डाटा को. It will be BIL sin theta. Even if you are not going to mention this, आप नहीं भी mention करोगे तो आपका नंबर नहीं कटेगा. But for your knowledge, ये जरूर याद रखना. But proof अभी नहीं पढ़ना है इसका. It will be BIL sin theta. Now let me explain you. What is that B? It is the magnetic field which created by the flux line. It is the magnetic field which created by the flux line. What is I? The total amount of current that flow through the conductor. And what is L? The length of that portion. Means for example AB, then it will be length. BC, it will be the rectangular coil. Breadth ले लो इसे आप. Again CD, it will be the length. And again AD, it will be the breadth. Right. So L is the length of that piece of the conductor. Right. Now this is the amount of force. Now अब एक बात हम आपसे बोले. अब सुनना जरा इस एक वर्ड को. Flux line, right now I will explain you कि this flux line always act at an angle of 90 degree, normal. And why we are taking the rectangular coil? अब मुझे जरा बताना. When we have the rectangular coil, then this magnetic field line or the flux line act on the side of this coil. तो जरा मुझे बताएं आप लोग. At AB, आप भी agree करोगे. On the side AB, it act at an angle of 90 degree. On the side CD, it acted at an angle of 90 degree. But on the side BC and on the side AD, it acted at an angle of 0 degree. That's why we are taking the rectangular. We need two sides. हमें दो साइड चाहिए जहाँ पे मैग्नेटिक फील्ड लाइन 90 डिग्री पे एक्ट करे. हमें दो साइड चाहिए जहाँ पे मैग्नेटिक फील्ड लाइन 0 पे एक्ट करे. Why? I will explain it. Right. So whenever we have a current carrying coil, then this current carrying coil always experiences an amount of force, and that force is given by BIL sin theta. Right. Now for the side AB, this theta is 90. For the side CD, theta is 90. For the side BC, theta will be 0 degree. For the side AD, theta will be 0 degree. Right. So that's why we are taking a current carrying rectangular coil, because they consist of 4 straight conductor AB, BC, CD and AD. Among these 4, 2 always act at an angle of 90 degree with respect to field lines, magnetic field lines, and 2 always act at an angle of 0 degree. Right. So this is the role of rectangular current carrying coil.